Hello everyone. Let's have a look at another example related with the heat transfer between two bodies that are radiating heat. So an industrial tunnel oven that is normally used to cook pizza, for example, is used here in this example, and we can see that the oven itself has a square cross section and it has sides of 0.5 meter. Okay. The top and the side wall of the oven are black and are maintained at 500 degrees centigrade. The oven is baked on a continuous slab of the pizza which covers the base of the oven. Okay, so we can actually approximate this oven as black body because first of all it has continuous temperature of 500 degrees centigrade, and also the walls are black, so it means that it is radiating all the heat from its surface towards the pizza slab. So the pizza slab is where we normally put our pizza, and it enters the pizza oven at 20 degrees centigrade, and the surface of the pizza slab has an emissivity of 0.6 because the pizza is here. This is the pizza slab, and the radiation is continuously heating up in this pizza slab, and this pizza slab is going to emit that heat to cook the pizza. Okay, so the surface of this pizza slab is emitting those radiation with the emissivity of 0.6 value. Now the question is that what is the initial rate of radiation heat transfer to the surface of the pizza slab per unit length of the pizza oven? Okay, so it's a very simple question. So we have the pizza slab here, and now this whole pizza slab is surrounded by this oven. So we and if you remember that in the last part of our lecture we talk about the heat transfer between two bodies, and we said that if one body is actually completely surrounded by with the second body or with a larger body, we can ignore the shape factor effect. So we can just take the difference between the energy, for example, emitted by the two surfaces. Okay. So in this case, all the heat is coming to the pizza slab from the surface of the oven. So we can use this equation here, and we have right here that Q dot, that is the heat rate of heat transfer, is equal to sigma, that is the Boltzmann constant, epsilon, that is the emissivity of the pizza slab, A, that is the surface area of the pizza slab, because the heat is coming from the oven to the pizza slab. So we do need to know what is the area of this pizza slab. We are not considering the properties of this surface because first of all we assume that it's a black body, and the oven wall, it means that its epsilon is 1. And the second reason we didn't consider its area is because it is completely surrounded by the this pizza slab is completely surrounded by this surface. So we are assuming that the surface area of this pizza wall is oven wall is much larger than the pizza. Okay, so that's why we can ignore it. And then we have the temperature of the wall of the oven, and then the temperature of the pizza slab itself. So this is very simple equation to remember, and the only thing that we have to do, we have to plug in the values. But before we do that, we have to calculate the surface area of the slab. Okay, so the slab is 0.5 meter in length, and because it's a square duct channel, so we do need to know the length of the oven as well. And here we are assuming that the length of the oven is 1 meter. So with that assumption, we can calculate what is the surface area of this slab. So that is 0.5 meter square. Okay. So now we know the area, we know Boltzmann constant, we know epsilon, we know the temperature of the wall. We need to know what is the temperature. We know the temperature of the pizza slab as well, and we can calculate the rate of heat transfer. So we just plug in the values. We have Q is equal to, and then if we plug in the values, we have Q is equal to 5,948 watt, and we can calculate we can approximate it as 6 kilowatt. Okay, So this gives us how much heat is coming from the walls of the oven to the pizza slab. Okay, and we can also, for example, calculate how long it will take to cook the pizza. So if we break this rate of heat transfer and multiply it with some time, so we can calculate how long, for example, it takes to cook the pizza, or how much quantity of heat it takes to cook the pizza, and how long it will take to get to that heat. Okay. Another important thing is that here again, as I said, that we haven't used the view factor, and the reason we ignore the view factor, or we consider it that it's 1, is because we assume that this slab of this pizza is completely surrounded by the oven. So all the radiation that is actually coming from the walls of this oven are being received by this pizza slab. Okay, so by that approximation, we can ignore the view factors that are much more complex for your level at the moment. Okay, so that's why we can make these simple, for example, approximations to simplify our equations. Okay, for our analysis. Thank you so much for your time.